And this is 8.4, number 73. We're supposed to solve the following equation. So we have z squared equals, or z squared minus 4 root 3 minus 4i equals 0. So if we solve for z, we would have z squared equals 4 root 3 plus 4i. And now we're starting to see something we've seen before. The idea is we want to find the roots of this. And so let's just call this a new vector. We'll call it v equals 4 root 3 plus 4i. And we'll need to find the magnitude of v, which is going to be the square root of 4 root 3 squared plus 4 squared. That's the square root of, 4 squared is 16 times 3 is 48, plus 4 squared is 16, so we get the square root of 64, which is 8. And then if we want to look at the angle here for this vector, tangent theta is going to be the imaginary part, which is our 4, over the real part, which is the 4 root 3. That gives us 1 over the square root of 3. So that theta would be tangent inverse of 1 over the square root of 3. And you may have seen that before, by the way, if it's helpful to see it this way, tangent inverse of square root of 3 over 3 from that chart that we memorized, remember, hint, hint. And that means it's going to be theta is pi over 6. And that's hopefully pretty clear, because if you look at the quadrant this is going to be, and this is the first quadrant, they're both positive. You get like 4 root 3 and 4, so someplace around there. So anyway, by our knowledge of the angle, that's pi over 6. So what does this do for us? Well, if we're going to try to find the roots of this, and in the past we used the w for the different roots, we can use z0 and z1 if we want to keep the similar notation. So we'll call z sub k is equal to the magnitude of v to the 1 over n power, I should say the absolute value of v, e to the I times theta plus 2 pi k all over n. And in this case, our n is 2, so n minus 1 obviously is 1. So we're looking for the k's to be 0 and 1, because we're looking for 2 roots, because it was a z squared. So our z sub 0 is going to be the absolute value of 8 to the 1/2 times e to the I times pi over 6 plus 2 times pi times k in this case is 0, so times 0 all over n. So that's going to be what? That's just saying 8 to the 1/2 power, e to the I times, that's just pi over 6. Oh, we know what n is, don't we? That's 2. I don't even need to put that. Let me change that to a 2. So pi over 6 over 2. So that's going to be the square root of 8 e to the I pi over 12. And that's going to be, what's square root of 8? 2 root 2 e to the I pi over 12. Okay, there's one of our roots. Let's find the other one. We'll call that z sub 1. And that's going to be the same absolute value of 8 to the 1/2, which we know is going to be 2 root 2. E to the I, this time pi over 6, plus 2 times pi times 1 all over 2. This works really good to be strong in your fractions. So we're looking at 2 root 2 e to the I, and that's going to be a pi over 6. Now 2 times pi times 1 is 2 pi. So if I want to have the same denominator, that's going to have to be a 12 pi over 6. And all that's divided by 2. So we end up with a 2 root 2 e to the I, so we have pi over 6 plus 12 pi over 6 is 13 pi over 6 over 2. So it's 2 root 2 e to the I 13 pi over 12. And there's your other root. Hope that makes sense.